Okay guys, today we're going to be multiplying fractions and mixed numbers. So you guys have been multiplying fractions, and remember when we're multiplying fractions, we draw a line through the numerator and the denominator. And looking at the numerator, we're going to look and see, all right, what numbers are prime? So we have 5 is prime, but 6 is not. So we do a branch. And we make 6 by multiplying 3 and 2. And 3 is prime, and 2 is prime. So in the numerator, we're going to write 5 times 3 times 2. And then when we look at the denominator, we're looking for primes. 9 is not a prime, but 11 is a prime. So we'll circle 11. And then we're going to look at 9. We're going to draw our branches. And we make 9 by multiplying 3 times 3. And 3 is prime, so we'll circle both of those. And so all our branches are done and we have our prime circled. So we're going to write 3 times 3 times 11 in the denominator. Now I'm looking for numbers that I can cross off that are the same in both the top and the bottom. I don't have a 5, but I do have a set of 3s, so I'm going to cross off the 3. And that's all I can cross off. So now I'm going to multiply 5 times 2, which is 10 in the numerator, and 3 times 11 in the denominator gives me 33. So what does this look like then when we have a whole number? Remember, we need to make that into a fraction, so we are going to put a line under it and put the number 1. Same thing, we're going to draw a line through our numerator and denominator, extend that line. 5 is prime, so we circle it. 10 is not, so we put our branches in, and we make 10 by multiplying 5 times 2. Circle the 5 and the 2, and in the numerator then, my primes are 5 times 5 times 2. And then looking at the denominator, remember 1 doesn't mean anything, so we're just going to ignore it. It's not a prime, but it's not, we can't make it by multiplying something else. So we're going to look at 24. 24, this one is 6 times 4, and neither one of those is prime, so I'm going to do branches under the 6, and that's 3 times 2. Those are both prime, and then I have 4, which is 2 times 2, and I circle those. So now all my primes in the denominator, 3 times 2 times 2 times 2. And then I can cancel. It looks like I can only cancel a pair of 2's here. So I'm going to have to multiply. 5 times 2 is 25. And 3 times 2 is 6. Times 2 is 12. Now this is an improper fraction, so I need to simplify this. And I need to say how many times will 12 go into 25? Well, 12 goes into 25 2 whole times. And I have 1/12 left over. So now I've simplified it into a mixed number. What happens when I'm multiplying a fraction by a mixed number? So this is a little different because now I have to make sure that I change my mixed number into an improper fraction before I multiply. So I don't have to do anything with the 1/2 because it is already in fraction form. But this 2 3/4, I need to change it into an improper fraction from a mixed. So when I look at that, I know I have 2 wholes and 3/4. So I need to multiply this whole number by the denominator 2 times 4. So 2 times 4 is going to be 8. So now I have 8 pieces there, but I need to add those 3 pieces that are up on top in the numerator as well. So I need to add that plus 3, and that gives me 11. And now the thing about this is the denominator didn't change. The pieces of pizza are still the same size, so we still are going to have fourths. Now instead of saying 2 whole pizzas with 3/4 of a pizza left over, we're saying if all those whole pizzas were sliced, we'd have 11 slices. All right, so rewrite the problem then. Instead of 2 3/4, we're going to rewrite it using 11/4. Okay. And then I'm going to extend my line between my numerator and my denominator. And I'm looking for my primes. Well, in the numerator, I only have 11. Remember, 1 we don't use. So 11 is there. And then in my numerator, in my denominator, I have 2. And then I branch under my 4, gives me 2 and 2. So I've got 2 times 2 times 2. Well, I don't have anything I can cancel. So I've got 11 in the numerator, and in the denominator, 2 times 2 is 4. 4 times 2 is 8. So I have 11 eighths. Well, remember, I can't keep it as an improper fraction. I have to see how many times does that 8 go into that 11. It goes in there one whole time. And counting up from 8, I get 9, 10, 11, whoops, I went too far. 9, 10, 11, which would be 3. So I'm left with 3 eighths left over. So my proper answer then would be 1 and 3 eighths. Okay, the biggest challenge is when we have two mixed numbers that are being multiplied by each other. Now we have to change these into improper. We can't separate them into whole numbers and fractions and multiply. We do that when we're adding and subtracting, we keep those separate, but not when we're multiplying. When we're multiplying, we have to change them into improper fractions in order to multiply. So remember, I'm going to do 1 times the denominator, which is 5, and that's 5, and then I have to add that 4, so I get 9 fifths, okay? And over on the right side, I've got 3 times the denominator of 3, which is 9, plus those 2 pieces up on top there, which is 11, and then I have 11 thirds because my denominator stays the same. So rewriting this problem, it's going to look like 9 fifths times 11 thirds. Okay. I'm going to extend my line between the numerator and the denominator, and I'm going to look for my prime numbers here. So 11 is a prime in the numerator. 9 is not prime, so I put my branches, and it's 3 times 3. Circle those. And then all my branches are done. I have all my primes, so I have 3 times 3 times 11. The denominator is a little bit easier because I have 5, which is a prime, and 3, which is a prime, so I don't have to do any branches there. I've got 5 times 3. And then I'm looking for a pair that I can cross off, and it looks like I got a 3 and a 3. So in the numerator, 3 times 11 is 33, and in the denominator, I just have 5. So how many times will 5 go into 33? Well, I know 5 goes into 36 times, so 6 wholes, and I've got 31, 32, 33, so I have 3 fifths left over. So my answer is going to be 6 and 3 fifths.